J1407b is one of the weirdest planets scientists have discovered. Located about 434 light-years from Earth, this is Saturn on steroids. Studying this eerie world, astronomers struggle to measure its mass precisely, but it's believed to be around 10 to 40 Jupiter masses. J1407b is also a giant planet, much larger than the biggest planet in our solar system. What shocked scientists was the planet's ring system of enormous size. It consists of 30 rings, each the size of tens of millions of kilometers in diameter. According to rough estimates, the diameter of the entire ring system is 120 million kilometers. This is 200 times larger than the rings around Saturn. If Saturn had its ring system this big, it would dominate our night sky. But although this would have been a breathtaking view, it wouldn't last long. The rings would eventually become thinner as several satellites would form around the planet. But that's just the beginning. The universe has stored a lot more bizarre worlds for us. How can one planet be hotter than the Sun and the other one larger than its star? How is there such a thing as a marshmallow planet? And what are planets? We've prepared a list of the most mind-blowing worlds for you. One of them is an exoplanet located 57 light-years away from Earth. Dubbed GJ504b, it's 4 times more massive but has just about the same size as Jupiter. The weird thing about it is, it's pink, quite an unusual color for a planet. So how did it get this color? The system is believed to be roughly 160 million years old, a newborn compared to our solar system. And because of the exoplanet's age, it's still changing and losing the heat of its formation, which gives it a dull magenta glow. But our universe doesn't only come in electrifying colors, it also has a lot of water-rich planets. A Neptune-like exoplanet, or the water world, has a mass of more than 8 Earths and a radius 0.24 times that of Jupiter. And although this alien world may seem promising due to its abundance of water, it's no Earth twin. The planet doesn't have a solid surface, and its atmosphere drastically differs from the one we have here. Because of extreme pressure and heat, it consists of water in a strange plasma form that behaves differently from that found on Earth. Despite the fact that the temperatures there reach 280 degrees Celsius, water on GJ1214b doesn't have the usual vapor, liquid, and gas phases, but rather a constant supercritical fluid form. So it has some properties of both liquid and gas, but overall, it's neither and both all at once. Now let's move to the constellation Cygnus. There, about 650 light-years away, sits a scorching world, Kepler-70b. With a mass of just 0.44 Earths and a radius 0.75 times our planet's, this is one of the hottest exoplanets known to us. The planet star, Kepler-70, was once a main sequence star like our Sun, while Kepler-70b used to be a gas giant the size of Jupiter. But about 18.5 million years ago, the star went through its red giant stage. As a result of spending a significant amount of time inside its now dead star, a hot iron core of the planet is all that's left. Scientists think the planet is still evaporating, which could eventually make it even smaller. So how hot is it? Because Kepler-70b is 65 times closer to its star than Mercury is to the Sun, the temperature on this exoplanet reaches a mind-blowing 6,650 degrees Celsius. To compare, our Sun's surface is only about 5,500 degrees Celsius. So, if hell exists, it must be it. About 640 light-years away from us sits yet another scorching exoplanet dubbed WASP-76b. But that's not the only thing the planet's known for. It also has a permanent dark side and molten iron rains. Discovered in 2016, it's nearly as massive as Jupiter. Since it's tidally locked to a star, the planet faces it at all times. The temperatures on the day side reach 2,350 degrees Celsius. This is more than enough to cause metals like iron to evaporate into the atmosphere. Additionally, the radiation that the day side receives is thousands of times more than our planet gets from the Sun. The dark side of WASP-76b is almost twice colder, Due to this extreme difference in temperatures, intense winds form on this exoplanet. Because of that, the iron vapor from the hotter part of the planet is carried by the wind to the colder side, and as this vapor cools, it rains molten iron. That's odd enough, but not as odd as the planet dubbed PSR J1719-1438b. But what's so impressive about it? This exoplanet is 3,000 times larger than its host neutron star. What's more, it wasn't always a planet. It used to be a star in the past. But let's start from the beginning. The exoplanet orbits an incredibly dense and tiny neutron star about 20 kilometers across. Only 1 teaspoon of this star's material would weigh billions of tons on Earth. The star is also a millisecond pulsar that emits beams of radiation while spinning every 5.4 milliseconds. This is about 10,000 rotations per minute. The star isn't lonely. It has a companion planet about 40% the size of Jupiter, PSR J1719-1438b. At the same time, this alien exoplanet is more massive than Jupiter. So how come it's so small and yet so massive? This is because the exoplanet was once a star whose outer layers were stripped away by a much more massive nearby pulsar. This left a carbon remnant of a star that became a diamond world about 5 times the size of our planet. It now has a diameter of roughly 60,000 kilometers, and because the exoplanet's proximity to the pulsar is very close, the whole system could fit within the diameter of our Sun. Space seems to be crowded with weird exoplanets, and some of them have properties so bizarre you could hardly believe these celestial bodies exist. Dubbed WASP-107b, this peculiar world has the density of cotton candy, which makes scientists revise their understanding of how gas giants form. While the exoplanet is about the same size as Jupiter, it's only 30 Earth masses, but Jupiter is 300 times as massive as our home planet. What's more, the core of WASP-107b is just 4 times bigger than the Earth's core, while it should be about 10 times that of our planet's. Because of all this, WASP-107b has an incredibly low density. In fact, it's like a marshmallow floating in space. So far, none of these worlds seem to be giving us any hope of colonizing them. But Gliese 581d could. Finding a planet that would be suitable for life is challenging itself, and it becomes even more so because of how far away most of them are. That's why Gliese 581d looks so promising. It sits well within 20 light-years from Earth and has a mass just about 6 times the Earth's. The exoplanet is in a habitable zone of its star, so the temperature could be right for liquid water on its surface. However, because it's tidally locked, one side of Gliese 581d is always warmer than the other. But it's not all that bad. Since carbon dioxide is abundant in the planet's atmosphere, it would keep the night side from freezing. While the Earth has its own regular day-night cycle and the majority of life forms here have adapted to live under such conditions, it's a big if the same could happen on Gliese 581d, given we colonize it one day. But if we do, the best idea would be to live in the region of habitability on the line that separates day and night, also called the Twilight Zone. The vastness of space is unimaginable, and 2MASS J2126 is living proof of that. This strange world was once thought to be a free-floating or lonely planet, but this celestial body isn't that lonely. It turns out that 2MASS J2126 moves through space along with a star, TYC 94869271. The weird thing is, both objects have been known to astronomers for years, but nobody saw the link between them. But then, scientists discovered the exoplanet and the star are both roughly 104 light-years from the Sun, which means they're connected. Later observations showed the planet orbits its star at a distance of 1 trillion kilometers. This is roughly 7,000 times the distance from our planet to the Sun. This makes it the largest orbital radius of any planet known so far. Interestingly, a result of such a huge orbit is that a year on this exoplanet equals about 900,000 Earth years. Now, let's get back to our solar system for a moment. The biggest planet here has 79 moons, so it seems logical exoplanets should have exomoons too. But for years, scientists haven't been able to find any. until now. Locating small cosmic bodies orbiting exoplanets is extremely hard. Nevertheless, astronomers have finally succeeded. But they didn't spot an exomoon. They found something even better than that. The first ever clear evidence of a moon-forming disk surrounding a huge distant exoplanet named PDS 70c. With the help of the ALMA telescope in Chile, scientists detected a disk in which satellites could eventually form, and its material is enough to make 3 of them, each about the size of the Earth's moon. For the first time in the history of astronomy, human beings could be observing how these small round worlds form in space, and not on a computer simulation, but live. The last exoplanet on our list is KOI 5AB, and what makes this one specifically unique is not its properties, but the system it's a member of. The planet about half the size of Saturn was first ignored because it was complicated and even considered science fiction. A decade later, the system named KOI 5 was given the scientific attention it deserved. It turned out astronomers stumbled across a triple star system. The planet revolves around Star A, which has a relatively close companion, Star B. They both revolve around each other every 30 years, but there's also a third gravitationally bound star, Star C. And this one orbits stars A and B every 400 years. If we could somehow travel to this exoplanet and hover on the edge of this world's atmosphere with our spacecraft, we'd be seeing breathtaking and unusual things. The bottom view would be most probably filled with dark brown and grey clouds, and instead of one sun, you'd see 2. One 17 times bigger than our star, and the other one quite smaller, and just about 0.5% as bright as our sun. But regardless of this, the fainter star would still glow 1,000 times brighter than the full moon here on Earth. No matter how unusual these alien planets are, there could be even stranger celestial bodies in our universe. So far, planets are usually hypothetical, but some scientists believe these could actually exist. If so, such mysterious worlds would form from the collisions of gas and dust particles surrounding black holes. These planets would also evolve at great distances from supermassive black holes, making their orbits million years long. The universe has no boundaries, not just in terms of distance, but also in terms of creativity. Now and then, astronomers discover mind-boggling space objects that broaden our limited imagination of the place we live in. It took us many years to discover all the planets of our solar system, and they're still surprising us with their properties. So who knows how much more eye-opening findings about the 5,000 known exoplanets are still ahead of us.